Alright, I got a circuit going on right here. It involves 2 switches, 1 LED, 2 pull-up resistors, and a whole lot of code. The goal of this program was to change the brightness of the LED using 2 switches, one for brightening it and one for dimming. And first off, I started with just programming one switch that turns the brightness up, and then from there I kind of did the reverse and changed it to where the other switch dimmed it. And it was kind of hard, but here's the code. Definitely my hardest program yet. That's why I kind of named it that, because I did it on my own and I had to think a lot. Holy moly, my screen. But yeah, I used analog read and then a whole lot of if and else statements. It's pretty cool how this works. You're like manipulating a bunch of data. So like there's 2 conditions here, because I don't want to be able to just hold it and that brightens it. I want to continuously tap it. So I had to add in like this next condition here, which is in line with this. Both of those are related. So that way when I press it, it changes the brightness, but I don't have to hold it. I don't know, I just thought that'd be cheating or whatever. And programming it like this was harder, but I learned a little bit more how the computer works in terms of reading the code and going from top to bottom. And here's if I want to dim it, so that's for this switch. And yeah, it's pretty sick. I'm using the concept of pull-up resistors, which so far I know them to be just a resistor that connects to the power directly, and using an input wire you can read that voltage, and when the switch is closed, or when the switch is open, you could read that voltage, but when the switch is closed, you don't read that voltage. And that especially comes in handy here, because that's what I'm doing. I'm analog reading the switch pin. So that's exactly what I need. I needed a pull-up resistor to do this program. But it's pretty cool. I learned about pulse width modulation, and as far as I'm concerned, that's like getting analog signals by digital means. So it's like you're kind of manipulating data also. So like, let's say I want to send like 2.5 volts to this LED. Well, it's not actually the Arduino sending 2.5 volts. It's pretty much with ones and zeros, right? That's how computers communicate. So 1 is on, 0 is off. In this case, my 5 volts, that's on, and then 0 volts would be off. It's actually 2.5 volts is actually the Arduino being on, or the being 5 volts for 50% of the time, and then 0 volts for 50% of the time, and it's doing that back and forth, and that eventually averages out to 2.5 volts, which is where I get the half brightness thing in the LED. I hope I explained that somewhat well. But yeah, here we go. It's getting brighter. And you see if I hold it, it won't get brighter. And that's due to that second condition in my if statement. So, brighter, 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 brighter. And then it goes back to like 0 essentially. And if I want to dim it, it blinks on the dim, which is kind of weird, but oh well, and then it's off. I learned a lot during this project. I learned about I already learned about this, but I guess I'm learning more. The AD converter, analog to digital converter, it's 10-bit, which means when I'm using the analog read function, the data that I'm getting back, so button val, which is actually being printed out in the serial monitor, that's the work of the AD converter within the Arduino. So 1023, that's a decimal number, and it represents a binary number that has 10 digits and they're all ones, which means it's all on. So I thought that was pretty cool. So if this was a binary number, it'd be like 111111111. And another crazy part is, so that's the analog read function, right? It's the AD converter is 10 bits, but the analog write function, I think it's called the PWM timer on the Arduino. It's like a component. That component, it's only 8 bits, which is why, like, let's say I wanted to like print out in the serial monitor switch bright, or actually no, I'm getting confused. But analog write, it's a 8-bit. That function or the component on the Arduino uses 8-bit information, whatever, data. So that means that's why the analog write, it only goes from 0 to 255, and 255, that's fully on, right? So, and if it's 8 bits, what would that mean the number is? It means it's 1. The binary number is 1111111. That's dope. So I thought that was pretty cool learning. I'm gonna start working with servos next, so that's the end of this project, but this is probably my most engaging one now. Oh, and a problem that I'm having is sometimes it's not fully 0. Sometimes it's 1, but that's an easy fix. I could change in the condition of the if statements, but I just need to like sometimes move around the wires, and then I'll get completely off. I think if I used a higher resistor, this is only 220 ohms, so if I use like a 10k ohm resistor, I think it'd be better, but it works. So yeah, pretty cool.